Hi everyone. In today's class, we would like to have some discussion about thermal power plant and steam power plant and hydraulic power plant. Okay. I am Dr. V. V. Kamesh, Professor of Mechanical Engineering, Aditya Engineering College, Sorampalam. Now I will share my video. Okay. So the learning objective of this video is to explain the working principle of the power plant. Now you can see power means energy, right? So energy can be identified, energy can be obtained by several means, right? That means it may be by coal power plant, thermal power plant, like both of them, and steam power plant, nuclear power plant, windmill, or solar power plant. Like this, we are having different types of sources. Okay. So here you can see in the screen, you are having hydroelectric power plant by fossil fuel, nuclear power plant, wind power plant, solar power plant. Now we will discuss about hydroelectric power plant. In hydroelectric power plant, see, hydro means water, right? So hydroelectric, that means current is coming by water, right? So here in the diagram, you are able to see some dam construction. You can see here. See, this is water. The total structure is dam, right? So here the water is stored at a high level, right? See the arrows I am seeing. This is the water. So now you can see the bottom right side. See, I am writing here, it is ground level. That means we are standing here. Okay. So the water is stored at a very high level, right? So the high level we are calling with the name head. Head means at a some very great height. Okay. So water is stored at a very high head, right? Now, in the bottom you are seeing this is generator. This is turbine, right? Now, water at a high high head or high altitude. So we are opening through a pipe. So water will come. See, I am putting some dots. That means water is flowing. Now the water is hitting the turbine and the turbine will rotate like this. Okay. Okay. So the turbine rotation is making the generator to rotate. Then you are getting electricity is distributed through other lines. Okay. Right. So this is the basic skeleton diagram of hydroelectric power plant. Now you can see the diagram from the reservoir. The water is flowing through. See. Now it is hitting your turbine here. So here we are putting some axial flow turbine called, in general, we are putting Kaplan turbine. Okay. We may put Pelton turbine, Pelton wheel turbine, or Kaplan turbine, or Francis turbine. So it depends on how much water we have in the reservoir, right? Suppose you are having very great height, right? So water is full. Then first option is Pelton turbine. Suppose in the medium level, okay, you go for Francis turbine. Water is at some low level, below 50%. Then you can prefer Kaplan turbine, right? So all the turbines are available at your hand. Depends on the water level, you can prefer Pelton turbine or Francis turbine or Kaplan turbine, right? So this is very simple skeleton of hydroelectric power plant so that you can explain well. And there is some deviation, some alteration. That means whenever your hydroelectric power plant reservoir water level is below average. So I told you earlier, you can prefer Kaplan turbine. Okay, right? But still, you are able to get some more energy by means of small diversion, right? Whenever you are having some gravity feeding, that means at a higher level to the lower level, water is flowing. Suppose you are making small diversion. In this diversion, if you put a small turbine, again, another turbine. So, by gravity, the water will flow automatically like this, right? Suppose I am putting another turbine here. So, another path like this, okay? So, like this from a high level. So, from this level to this level, if you are flowing the water directly, I don't get any turning of turbine. So, I will put a diversion and through the pipeline, I will come again. Water will come again and in the meantime, there will be some rotation. So, this is called diversion generation energy. Okay. Now, you can see reverse pumped storage. These pumped storage means, so you are seeing the water is flowing in the reverse direction, right? Whenever you are having excess energy, that means energy is not at all stored. Okay. Once the energy is released, you need to use it, right? So what I can do? Suppose we are having excess energy. Generally, in the winter season, we are having excess energy, right? In the winter season, generally we don't produce hydroelectric energy, right? Suppose you produce, it becomes suppose excess. Then what I can do? So I will pump the water in the reverse direction so that water will be stored in the reservoir. Suppose you produced, but it is not at all used. So reverse, because we are unable to store very high amount of energy in the batteries. Batteries can store very small energy, right? Compared to our requirement, batteries can store small energy only, right? Even though we are having the battery capacities for one organization, it is limited to one organization. Compared to power plant capacity, batteries capacity is less. So what we need to do? We pump the water in the reverse so that whenever there is a need, again you open the valve and let the water come down and generate the energy. Okay. So this is called when the high demand is there, we will release the water. When the demand is low, we will pump the water back. Okay, this is regarding hydroelectric power plant. In the next video, we will complete the thermal power plant or coal-based steam power plant. Okay, thank you very much.